Sequence and series. If a sequence has alternate sign, then it must be preceded with the term minus 1 to the power n, and it depends on if the number, the term is negative for the odd term, like the first, the third, and so on, then it would be minus 1 to the power n, right? When the first term is 1, then it's negative. If it's 2, then it's positive. But if it starts with a positive sign, then the coefficient would be minus 1 to the n plus 1. So that's one point there about series. So example, like an is equal to minus 1 to the n over 2n plus 1. So the question would be like when it asks for you to find the formula for the sequence that is like alternating minus plus minus plus, then you always have to remember to put this coefficient in. If it starts with negative, then it's this one. If it starts with positive, then it's this one. So to find the formula is like the first two terms must be given. Then you can kind of like, try to find it. So to find the nth term of a sequence, if the formula is given, then you just substitute the number for n. For example, n would start from 1, 2, 3, 4, and so on. If an is 2n minus 1, then the first term would be 2 times 1 minus 1, which is 2. 2 times 1 minus 1 is it's just not that. So this one, an, for B, it says these are the terms. So apparent pattern, it has alternate sign, so that means it's gotta have like the coefficient minus 1 to the, and this starts with positive 2, so it's n plus 1 because the first term is positive. So you know that this is the first term, so this is the answer. And then you've got to find like the terms for other terms, and so we just look at this. So it's 2 is 1 plus 1, and then 5 is 2 to the 2 plus 1, 10 is 3 to the 2 plus 1. It's just using like the trying to see the pattern. 17 is 4 to the 2 plus 1. So the number itself is n to the 2 plus 1. So this is the formula for the sequence. Next example, write an expression for the apparent nth term. So you've got to find the formula basically. And so the difference is it could be geometric series or arithmetic. Anyway, so this one, we just try to see what goes on. So in this case, the gap between this, to find if it's arithmetic, the gap would be constant. So the gap is 4, and then 4, and then 4. So that means it's arithmetic sequence that starts from, it's like 4 times n minus 1. So the value would be 1 plus 4 times n minus 1. For example, this is 1, this is the second term. The second term would be 1 plus 4. And then the third term is, this is 3, right? N would be 3. So 3 minus 1 is 2. 2 times 4 plus 1. And then the fourth term is 3 minus 1, no, 4 minus 1 times 4 plus 1, which is 13. Yeah. So, and then for B is alternating. So, and it starts from the power positive. So it's minus 1 to the n plus 1. And then this is like 2 times 1, 2 times 2, 2 times 3, and so on. So the term here would be 2 times n. Now a recursive sequence. First, write like what it means is all other terms. The recursive means all other terms are defined using the previous terms. So for example, AK is written by defining by using AK minus 1, which is the previous term. So example in this case, A1 equals 3, AK equals 2, AK minus 1 plus 1. So A1 equals 3, then A2 equals 2 times A. 2 minus 1 is 1 plus 1. And then go on and on. So this is recursive formula. And so example, Fibonacci sequence, a recursive sequence. Fibonacci sequence is defined recursively. So A0 equals 1, A1 equals 1, AK equals AK minus 2 plus AK minus 1 is just the name of this term, this kind of series where K is greater than or equal to 2, and you just substitute it. So A0 equals 1, A1 equals 1, A2 equals A2 minus 2, just use the formula, plus A2 minus 1 equals A0 plus A1, and then just substitute the values. Factorial is another kind of sequence that's defined by factorial sign. Now summation is just, summation from 1 to n, that's a notation. And then there's a property, there are properties of sums, which summation I equals 1 to n of c equals c times n. C is a constant. And then summation of AI plus BI, you can just like give sum to each term, so it's equal to summation AI plus summation BI. Summation CAI, you can pull constant out, so it's equal to C times summation AI. and this you can give summation to each term. Now series is the definition of series is the sum of the terms of finite and infinite sequence. So sequence is just like sets of numbers that has relationships. Series is the sum of the terms. It could be finite sum or infinite sum, infinite series or finite series. So finite series is just summation from I equals 1 to n of ai, the sum of n terms. And then infinite series is we sum until like n approaches infinity. So summation I equals 1 to infinity ai. So finding the sum, the third partial sum, this is partial sum means like the finite series. Then just substitute I equals 1, 2, and 3, and then you get 0.333. And then sum of series, you just add until like n goes to infinity. Then you will see that as n gets larger, this becomes like almost 0. And you can kind of see the pattern that is 3, 3, 3, 3, 3, infinite, which basically is equal to 1 over 3 for this case. Now, compound interest. No. That's a formula for the series, which is not here. It's on the other side. So application, compound interest. Example, an investor deposit $5,000 in an account that earns 3% interest compounded quarterly. So AN equals, given this one, write the first three terms of the sequence. So A0 equals 5,000 times 1 plus 0.03 over 4 to the 0, then is equal to this. Compounded quarterly means that in 1 year it's compounded 4 times. So this would have to be divided by 4. The formula is AN equals P times 1 plus I, this is or R, in yearly over number of times it's compounded. So if it's compounded monthly, this would be divided by 12 to the n. And n is the number of times, like number of quarters or number of months that is compounded, basically. Or if it's given in years, then this would be number of compounded, this is number, and this is number of compounded times t. T is the year, and n is the number of times compounded by per year. So for example, if this is 4 times, so this would be 4 times t, which t is in year. And if it happens to be half a year, then it's 0.5. That means it's compounded 2 times per year. This would be 2. So the nth term of the sequence is just substituting this by n. So for 40th term of the sequence, that is the 10 after 10 years, because in 1 year there are 4 times of compounded. So after 10 years it's going to be the 40th time that is compounded. So basically it's asking for us to find A40. Now, arithmetic sequence is when the gap is a constant. So in other words, A2 minus A1 equals A3 minus A2 and equals a constant D. This is the definition of arithmetic sequence. So the gap would be constant, the gap between successive numbers. So the nth term of arithmetic sequence can be written by an equals a1 plus n minus 1 times d. So if we are asked to find the formula, this one would be a1, and then you find the gap between the two, so it's going to be d, and then an equals a1 plus n minus 1 times d. That's the arithmetic sequence. Yeah, you can just use the formula and then just do it. And it can also be written in terms of recursive, or like it doesn't need to be written down all the way to a1. It can be, let's say an is equal to a1 plus n minus 1. So A13 is going to be A4 plus what times D. So the gap would be between 13 and the fourth term. So this is like what it is. So this is 9. So if you want to write, A12 in terms of A9, it would be A9 plus 12 minus 9 times D. So an plus 1 is equal to an plus d, and ak, which is the like A13, right? So AK would be equals to AP, AN would be equals to AK plus n minus k times p, for example. So just like just like that example that I just told you about. Example, find nth term of arithmetic sequence that begins with 2. Find the 9th term of arithmetic sequence that begins with 2 and 9. So the first number is 2, the second is 9, the gap is 7. So then an would be a1 plus n minus 1d, which is equal to 2 plus n minus 1 times 7. And then so a9 is equal to 2 plus 9 minus 1 times 7, which is just this one. Now, sum of a finite arithmetic sequence is Sn, and is given by n over 2 times a1 plus an. So you can just look at the formula and use the formula. Example, find the sum of 40 plus 37 and so on. So we can see that is arithmetic sequence by seeing the gap. 37 minus 40 is minus d. So d can be a negative, like it's decreasing. And this, you have to check at least 2. Just check for all, right? 34 minus 37 is minus 3. So d is minus 3. And then Sn equals n over 2 times a1 plus an. So S in this case, n is how many terms there are. So 1, 2, 3, 4, 5, 6, 7. There are 7 terms. So n is 7. A1 is 40. The last one is A7. So A7 is 22. A1 is 40. You just substitute it in the formula and then find the number. Another example, find the 16th partial sum of this. So A1 is 100. And then we find the gap. D is 95 minus 100 equals 90 minus 95, which is minus 5. So D equals minus 5. So then we write the formula of the term. An equals A1, which is 100, plus n minus 1 times d, which is minus 5. And then it's asking to find the 16th partial sum. So we have to find A16, which is 100 plus 16 minus 1 times minus 5. And then we use the formula Sn equals n over 2 a1 plus a2. So Sn equals n over 2 plus a1 plus an. Which in this case, n is 16. So A16 equals 16 over 2 times A1, which is 100, plus A16, which is this number, turns out to be 25. And you calculate, you get 1,000. Now, geometric sequence is dividing, you get a constant. In other words, the second term divide the first term equals constant, and the third term divide the second term equals constant. And the formula of an equals a1 times r to the n minus 1. This is geometric sequence. Geometric sequence. And also, if you're not starting from the first term, which means that AP is equal to AK times R to the P minus K. For example, A10 equals let's say if we start from A4, it's going to be A4 times R to the 10 minus 4, which is A4 times R to the 6. So this is the tip. And all of this is in the first page of the formula, the working that I gave you. So example, finding a term of a geometric sequence A10, the fourth term equals 125, so A4 equals 125, and then the 10th term, A10 equals 125 over 64. Find the 14th term. We want to find the formula. A K equals, it's just like A10, right? Equals A4 times R to the 10 minus 4. And then it's 125 over 64 equals A4 times R to the 6. And A4 is 125. So R to the 6 is 1 over 64. So we know that R is 1/2. So then we get that we don't need to work all the way to the first term, but now it's just asking to find 14th term, which we can start from the 10th term, or we can start from the 4th term, right? So in this case, we'll start from the 10th term. So A14 is equal to A10 plus R, which is 1/2, to the n minus k, so 14 minus 10, which is 14 equals A10 plus 1/2 to the 4. And A10 in this case is given is 125 over 64. So it's equal 125 over 64 plus 1 over 16. And then you can simplify it. Now, sum of finite geometric sequence is given by this formula. You just have to be able to see that whether it's a geometric sequence or arithmetic sequence. So example, this one is geometric sequence, and then you just use this formula and then substitute. Now series is just the sum, right? Which can be finite or infinite. The sum of infinite geometric sequence, this is finite, sum of finite geometric sequence, and then this is sum of infinite geometric sequence is A1 over 1 minus R. So just need to be able to identify what A1 is, what is R, like that.